Hello, welcome to the last part of the second module of StatMech. In here, we are going to see the second example of microcanonical ensemble. Okay, so in our last classes, we have dealt with what a microcanonical ensemble is. It is where N, V, and E are kept as constants. Okay, for microcanonical ensemble. N, V, and E are constant. But in the first case of ideal classical ideal gas, you considered energy not exactly E, but between a small range, because in practical conditions energy will fluctuate a little anyways. Okay, so there also you were treating the energy within a range. The second example is obviously the harmonic oscillator. So you have a one-dimensional harmonic oscillator. So for harmonic oscillator, all these equations we already know, right? The Hamiltonian is what? Kinetic energy plus potential energy. ശരിയല്ലേ? So kinetic energy is what? P square by 2m. Potential energy is this one, right? It is interchange, but never mind. Okay, and you know that the solution of harmonic oscillator is sinusoidal, so that has to be a cos function or a sine function. The general form is q is equal to a cos omega t plus phi, and p is nothing but mass into q dot, right? Mass is mass, and if you can differentiate a cos omega t plus phi with respect to time, then you will get rest of the term, right? This you already know. Now if you can put the equation for q here and p here, then you will eventually get the equation for energy, which is half m omega square a square, where is the amplitude, right? Amplitude. These things you already know, and you have studied this in the smaller classes, so I'm not going to this in detail. So you can just rearrange this equation. uh, this is q. You can find q by a. Q by a is cos omega t plus phi, and you can have p minus p by m omega a minus p by m omega a. This is sine omega t plus phi, right? Now this is a trick. This is a standard trick where you isolate cos function and sine function. Then what you do is you will square and add, right? Square and add, because cos square theta plus sine square theta is equal to 1. So you will get a simplified equation. So that is our motive. So if you can square and add, then you will get this equation, right? This one q square by a square. This one minus will get cancelled. P square by m square omega square a square equal to 1, right? Now you can put this thing in perspective. You can replace a with from the equation of energy. You can replace a in terms of energy. So it would be 2e by m omega square. Rest is kept as it is. No, yeah, here also m square omega square a square. That is 2me, right? This is 2me. So what you have now is q square by 2e divided by m omega square plus p square by 2me equal to 1. So you very well know what the equation means. This equation is equation of an ellipse. Ellipse. So ellipse in the equation the form and the h square by a square plus y square by b square equal to 1, right? Now A is semi-major axis, B is semi-minor axis. A is semi-major and B is semi-minor axis, right? So, you know what is the area of an ellipse, right? If this is an ellipse, then you have semi-major axis and semi-minor axis. This is semi-major axis. This is semi-minor axis. Semi-major axis is A. This is B. So area of ellipse will be pi AB. This is a fact which you already know, right? So area of ellipse, that is equal to pi AB, that is equal to pi into this term into this term, right? How I get this term, these two terms? Because because the equation of ellipse is x square by a square plus y square by b square equal to 1. Now you know what a is, you know what b is, right? So the area of ellipse is pi AB. You just substitute for A, then B. What you get is 2 pi E by omega. Okay. Now there is an issue with this because omega is, we have been using omega for phase space. Okay. So this is uh, if I put omega here, then later for phase space also I use omega, so that will be under you will be in confusion. So I will change this to nu. Okay, I just put that omega by 2 pi is equal to nu, so I can write this as what, uh, e by nu, right? This is e by nu. Okay, now if I restrict my oscillator energy between a limit e minus delta by 2 to e plus delta by 2, which is as shown like this in the figure, right? Because now you are dealing with trajectories that are ellipse, right? So it has to be drawn in the form of ellipse in phase space. Okay, now you are restricting the energy which is between minus delta by 2 to plus delta by 2, right? So for that you need to find out what is the phase space omega. This is phase space omega, so phase space omega is equal to what? Integral dq into dp, right? Since this is one dimensional, what is dq into dp? That is and the energy is between e minus delta by 2 and e plus delta by 2. So these two ellipse, right? You need to find out the area in between these two ellipse, right? For that you just need to write what is the difference between this whole area and this whole area, right? So area of the first ellipse minus area of the second ellipse will give you the shaded portion. So A2 minus A1. A2 is what? 2 pi by omega, right? Omega can be, I just cancel 2 pi and I put nu here. Okay. So this is nu into E delta by 2 minus E minus delta by 2. That would be equal to delta by nu again, right? I'm avoiding this omega because here also we are using omega, so I don't need this omega. I just deal with frequency nu because omega is angular frequency, nu is frequency. Okay, and from quantum mechanics, you know that energy of harmonic oscillator quantum mechanics is En is equal to n plus 1 h cut omega n is equal to 0 1 2 3, right? So the first ellipse will be of n equal to 0, second ellipse will be of n equal to 1, third ellipse will be n equal to 3 2, fourth will be n equal to 3. So this is the place where representative points moves, right? This is the trajectory of representative points. Okay, so you have this equation for a harmonic oscillator, okay, quantum mechanically. Now if I need to find out the phase space between two trajectories, now this is the phase space between two trajectories. If I find out the area of phase space between these two trajectories, you have one trajectory here, you have another trajectory here. Quantum mechanically, the energy difference will be what? H cut omega or h nu, right? Because if you find out the difference between two levels, that is En minus 1, you will get h cut omega. In order to avoid confusion, I just write h nu. Okay. Now we need to find out what we have phase space. We have the equation for this phase space area, which is equal to 2 pi delta by omega. Okay. Now from this equation, this is 2 pi delta by omega, which is equal to delta by nu. Okay, I just write this as I will just write this as delta by nu, that is equal to what? That is equal to delta is what? H nu divided by nu, and that is equal to h, right? So we have the phase space that is equal to h. Okay. Now if you want to find out, we know this equation, right? E is the maximum energy, delta is some energy in between, okay, and h cut omega is the fundamental energy difference, right? So number of microstate within this interval delta is equal to, okay, you have this energy interval delta, okay, this is energy interval delta. So number of microstates in this energy interval delta will be delta by h cut omega, because or I will say delta by h nu. Okay, so delta by h nu is the number of microstate within interval delta, right? അപ്പം എനർജി ഇന്റർവെൽ ഡെൽറ്റയാണ്, ശരിയല്ലേ? അത് എത്രയാന്ന് നമുക്കറിയില്ല, അത് നമ്മൾ എടുക്കുന്നത് പോലെയാണ്. ഏറ്റവും മിനിമം എനർജി എന്ന് വെച്ചാൽ എച്ച് ന്യൂ ആണ്, ശരിയല്ലേ? അപ്പം ടോട്ടൽ നമ്പർ ഓഫ് മൈക്രോസ്റ്റേറ്റ് എന്താ? നമ്മൾ എടുക്കുന്ന എനർജി ഡിവൈഡ് ബൈ മിനിമം എനർജി. സോ ആ റേഞ്ചിലുള്ള ടോട്ടൽ നമ്പർ ഓഫ് മൈക്രോസ്റ്റേറ്റ്സ് വിൽ ബി ഡെൽറ്റ ബൈ എച്ച് ന്യൂ. ഓക്കെ, സോ ദ ഏരിയ ഓഫ് ഫേസ് സ്പേസ് ഇക്വാലൻ ടു വൺ ഐഗൺ സ്റ്റേറ്റ്, അതായത് ഒരു ഐഗൺ സ്റ്റേറ്റിന്റെ ഏരിയ നമ്മൾ മുന്നേ എങ്ങനെയൊന്ന് കണ്ടുപിടിച്ച ഒമേഗ സീറോ ഈസ് ഈക്വൽ ടു ഫേസ് സ്പേസ് ഡിവൈഡ് ബൈ നമ്പർ ഓഫ് മൈക്രോസ്റ്റേറ്റ്സ്. അപ്പം area of phase space equivalent to one eigenstate will be omega by number of microstate. Omega by number of microstate. Omega നമ്മൾ already കണ്ടുപിടിച്ചിട്ടുണ്ട്. Omega is delta by nu, right? And number of microstate is delta by h nu, right? So omega 0, which is the area corresponding to one eigenstate, equal to delta by nu divided by delta by h nu, that is equal to h, right? So that is the area of phase space equivalent to one eigenstate. Okay. Now for an n-dimensional harmonic oscillator, the area of phase space equivalent to one eigenstate for n-dimensional harmonic oscillator is h raised to n. ഓക്കെ, അപ്പോൾ ഇതാണ് നമ്മുടെ നമ്മളുടെ മൈക്രോ കനോണിക്കൽ എൻസെമ്പിളിൻ്റെ ഒരു എക്സാമ്പിളും കൂടി. അപ്പം രണ്ടിൻ്റെ കേസിലും, ഇതിൻ്റെ കേസിലും ക്ലാസിക്കൽ ഐഡിയൽ ഗ്യാസിൻ്റെ കേസിലും അതുപോലെ ഹാർമോണിക് ഓസിലേറ്ററിൻ്റെ കേസിലും വൺ ഡയമെൻഷൻ ആണെങ്കിൽ നമുക്ക് മിനിമം വോളിയം എന്ന് പറയുന്നത് എച്ച് എന്ന് തന്നെ കിട്ടും. ഓക്കെ, അതാണ് നമ്മൾ ചെയ്ത ഇത്. സോ ഇതോടെ നമ്മളുടെ സെക്കൻഡ് മൊഡ്യൂൾ കഴിഞ്ഞു. നിങ്ങൾക്ക് എന്തെങ്കിലും സംശയം ഉണ്ടെങ്കിൽ നിങ്ങൾ എന്നോട് ചോദിക്കുക.